you are here, I assume that you are already done with the for loops and control statements because I am also going to discuss some of examples on manipulating data structures using these for loops and all. So if you are not yet confident, just click on the card which is shown above and just revise the topics once and get back to this video. For now, let me dive into data structures that really matters in Python. If I tell you that there are just four main data structures in Python, which are generally used to play with data. So let me list them out. List, tuple, sets, and dictionaries. So these four data structures are mainly used in Python. Let us walk through each one step by step so that we build some understanding what actually these data structures are meant to. So these data structures generally have three properties. If I observe list, we have ordered, mutable, and duplicates allowed. So we are going to hear these keywords again and again in this session. So I want you to focus on what actually ordered, mutable, and duplicates refers. So whenever I term the word ordered, it refers that the particular data structure I am discussing about follows a particular order while it's printing the output. Then what is mutable? Here, mutable word refers to the property of data structure which allows us to modify the data which is stored inside the data structure. When it comes to list, list is ordered mutable. That means it is going to store elements in particular order and also going to print the output in the same order that it stores. And when it comes to mutable, list can also be edited after its creation. List can be edited or modified after its initialization. And do list contain duplicates? Yeah, list allows duplicates, so we can enter any kind of data into list. Actually, list is the simplest data structure among these all four. So it does not have any restrictions. Like, okay, it just maintains the order. It is mutable. It can be edited anytime, and it also allows duplicates. So it is the simplest data structure that I see in this book. So I want you to imagine this list as a container that stores different data. Here we have a container called fruits, like the variable called fruits, which stores multiple fruit because I see three fruits right here, apple, banana, and cherry. It is storing all these entities into one variable. That means it is bundling. In generally, it is bundling the variables and storing it in one single variable. And we can access these through a technique called indexing. I will show you that. Before that, if you want to make a list, you use these square brackets. Inside these square brackets, you store the entities that you want to store. So I just initialized a fruits list and I will just show you the output. You can see that it is just giving back the list that we store. How many times I execute this block, it is going to give the output in same format that I stored the values in. So this is the meaning of ordered. List is going to remember the order which I store the data in. Now, as I said, we can access each element of list using indexing. This is what indexing means. List has multiple elements. How we keep tracking of them. So we generally assign indices to each element of the list. Indexing starts from 0 and goes on up to the length of the list. So if I observe here, apple, banana, and cherry. I'm currently holding three fruits. Now what I do is I start indexing apple as 0. That is first element is going to be 0th index and the second element index is 1 and third element index is 2. Like this, it goes on until the list ends. So you just need to remember that indexing starts from 0 and ends till n minus 1 if you assume n as a length of list. So now index of apple is 0, banana is 1 and cherry is 2. So when I want to access apple which is first element of the list, what I will just do is that I will write the name of the list that is fruits variable name and the index that it is stored. Apple is stored in the 0th index. So we write 0. Now it should print us the output as apple. In this indexing topic, we also have a concept called negative indexing. When we index in positive numbers, we start from 0. Similarly, when we start negative indexing, that means we are going back and coming front of the list. We generally index from back side of the list when we are talking about negative index. Now, negative indexing starts from -1. Here, cherry's negative indexing will be -1. Now, banana will be -2 and apple will be -3. If I want to access cherry, I can just do this. Fruits and -1. I will show you two ways of accessing elements with positive and negative indexing. First one is negative indexing. For the negative indexing, I just wrote that -1 because it is the last element present in the list. Now, when I come from forward, that is positive indexing, here 1, 0, 1, and 2, cherry and cherry. I hope you understood the concept of negative indexing and positive indexing. Now, let us discuss actually how are we going to modify the list that we have created right there. Think that I have a fruits container which has three fruits. Now I want to add another fruit called orange. What I will just do is that I use the method called append. Here the append method adds any element into the end of the list. Now whenever I use append, the element which I am going to add is going to be added at the end of the list. So when I print, let me just comment this out and show you the output. Let us go step by step. So yeah, now you can observe. Currently, we was having apple, banana, and cherry. Now, one more fruit was added, that is orange. I hope you understood what append does. It just adds the element at the end of the list. Okay, in some cases, you want to insert at certain point. Like, I want to insert this grape at between apple and banana. Then, what will be the index after inserting the grape? So, what will be the index of grape? It should be 1 because grape is going to be second element after insertion. So we generally mention the index where this data should be inserted. Insert method is generally used to add any data anywhere in the list, whereas append is generally used to add the element at the end of the list. So I am going to insert this grape between apple and banana. Now you can see that apple, grape, banana, cherry, and orange. Now we have 5 rows. Let's go, bro. Okay. Now I am so hungry, so I just want to take any one of the food. Here I go with banana. So what I will do, I am trying to remove an element from that list. So I use the method called remove. Till now we have completed append insertion. These both methods were used to add element into list. Now here comes the concept of removing. So whenever you want to remove particular element, you just use the method remove and remove that particular element directly. Instead of mentioning index, we just mention the actual value. So I'm just removing this banana. So you can see that banana is got removed. Next, we are going to discuss pop. Now, what this pop do? As you understood that append is going to add element at the end. Similarly, pop is going to remove the element from the end. Whatever element might be present in the end of the list, it is going to be popped out. So I don't need to specify any value. Now, when we move to modifying particular element of the list, here I want to change the apple, which is at zeroth index, to mango. How would I do? I just access the location of apple, which is generally done by indexing. So at zeroth position of fruits, whatever the data it is, I'm going to overwrite it with mango. Now this apple is going to be converted into mango. Our list got modified. Mango, grapes, and cherry. I hope you understood all these methods. Now, let me show you a mistake that beginners generally do. Observe this. What I am doing, I am assigning fruits, which is this container. Now, initial fruits container is this. I am assigning these values to basket. Directly, I am just directly writing the variable fruits assigned to basket. They are just copying the reference, that is the location of the fruits, not the entire list. Anything that you modify in basket variable is also going to affect fruits. Generally, we are storing the reference of fruits in basket. So whatever you whatever method you apply to basket, it is going to affect the actual data of the both containers, basket and fruit. Here we are generally linking these both variables, appending orange into basket. That means generally what will happen? Fruit should not be modified, right? Only orange should be added to basket. But here, as it stores the reference, we are going to get this output. See, both are pointing to same memory location. So both got affected. Now orange is present in both basket and fruit. Now what you have to do when you want to copy entire list into another variable? We use concept called slicing. I'll explain this. You just remember this notation when you want to copy entire list. Here we just do this using concept of slicing to copy fruits into box. When it comes to concept of slicing, we are allowed to pass three arguments, start, end, and step. These arguments are separated by semicolon. Observe this. Here I am passing an empty colon. That means there is no value before colon and after colon. That means I am setting the default values of starting and ending. It starts from zero and goes until the list ends. And there is no step. That means it is going to read every element of the list. So it is going to copy entire element from zero to length of list into box and now see the output. When I append banana to box, it is not going to affect the fruit. Whatever I modify to box is not going to affect the fruit. We are going to get two different outputs here. Now, fruits already has mango, grapes, cherry, and orange. This orange was added here, right? Now, additionally, I am adding fruit banana to box. You can see the difference between two outputs. I don't find any banana in fruit, whereas I find banana in box. This notation is generally followed to copy particular list. Now, when it comes to slicing, we can, as I said, we can mention start and end of slice. The elements from index 1 till 3, the elements which are presented 1 and 3 are going to be printed. As you can see, elements at first and second index are grape and cherry. So we got output as grape and cherry. These are generally used to access limited data from the actual list. Here comes the key use of lists. As we mentioned that list can store many elements inside a single variable. This is taken as advantage to store numbers dynamically. Observe this. I have a list called numbers, which stores numbers from 1 to 5. Now I want to square each element in the list and store it in the variable called square. In this particular example, I am writing it in a single line. So observe this here. I am iterating elements from numbers list and taking this object as n. For every n object inside the list, I am squaring it up and just giving this as output. Now, this list is going to store all the outputs from this for loop and give us the result directly in the list form. As you can see, it just computed these and gave us output as squares of all numbers. See that? It's so powerful, which could be written in one single line. In other languages, you need to write at least 3 to 4 lines of code for doing this, whereas Python does it in single line. Whenever you want to concat two lists into a single list, you just generally use extend keyword and sort. Sort is generally used to sort elements inside. As you can see, this list got sorted. Now, whenever you use sort, observe that it is going to modify actual list. The sort is in place. That is, the list itself is modified. I hope you understood the basic concepts of list and their operations. Now, if you are also excited to learn about tuples and other two data structures, just click on this video. I will meet you on the other side. Until then, this is SP signing off.